Good morning, guys. We're here in Oxnard, California at the Haas factory, and today we're going to give you a tour of pretty much the whole facility. So let's go in through the front entrance here and get started. All right, so this is the main entrance, of course, the lobby here. Now we've got racing memorabilia on each side from all of Haas's race teams, but we're not going to look at that right now. Demo room's over there. We've got another video that covers that. Right now, we're headed towards the machine shop. We're here in building 1, of course. We've got 4 buildings on campus here, totaling over 1 million square feet under roof. And we're going to start in building 1 on the machine shop side, as I just said. Right here, actually we're on the other side of this wall, is rotary assembly. We'll be coming back to that quite a bit later here in the video. Right now, we're headed towards the machine shop side of building 1, and this is where we house a lot of our FMS systems. So, building 1 machine shop side. As you can see here, we've got some rotary table bodies that are surrounded by them actually. HRT 1000, our largest rotary table. TRT, rotary bodies, and trunnion castings. HRT 310s, 210s, 160s, runs the whole gamut. But on this left side here, this is kind of what we're going to focus on for right now. All throughout the factory here, we have a variety of different FMS cells, or flexible manufacturing systems is the long name for them. Right here we've got these machinos tended by these pallet walls here, and really this just signifies Haas's investment in the right tool for the job. We've been using large FMS cells since before I started in 1997, so the concept and reasons are well founded. But we continue to make new investments in these systems because it's the right approach in some cases. People ask, why aren't you using Haas machines throughout your entire factory? And the simple answer is, these large HMCs and pallet stackers are not the market segment that Haas is building machines for. But it is the right tool for the job in this case. A high mix of parts at a medium volume makes these pallet stackers ideal. The concept is simple really. Machine the right part at the right time here in the machine shop so that part is ready to put together on the assembly side of the factory when it's needed. And keep these spindles turning as much as possible. All right, so we're leaving this the Makino FMS cells. We've also got some Japanese ones down that way. Rounding the corner, we're going to head down this aisle here where we've got a whole line of EC400s. Now these are our earlier version, not the present one. Most of these machines were installed between 2012 and 2014, so 6 to 8+ years old. Now this is kind of an example, well this is completely an example of how Haas does the same style of machine as those FMS systems we just looked at. But in this case, it's geared towards a medium-sized shop at a much more affordable price level. But the idea here is that these horizontals are aimed at getting a high mixture of parts, or maybe you're focused on one specific part. All of these cells are mostly concentrate on 1 or 2 parts or a few parts where we're doing very high volumes. But you can see, when you attach a pallet pool like this to one of these HMCs, you've got a lot of fixture positions, and the idea is with the pallet pool loading and the pallet changer loading those pallets in and out of the machine continuously, your spindle on time is maximized. You can see right here, we're making motor housings for our machines. Just one example of all the different parts we make on this line here. All right, so we're right next door to where we just looked at those EC400s. Now you can see we've got this line of BMC 1000s. These replaced older models just recently, but the idea is the same here, just for much larger parts. Each one of these machines has 10 pallets, and you can see we've got a variety of different castings. We've got saddles, bases, just a huge part mix, but on these huge 1,000mm pallets, the focus is large parts, of course. All right, moving on from those FMS cells, this is one of our 2 cylindrical grind areas. We've got kind of a variety of robot-loaded and manually loaded cylindrical grinders. And you can see right here, we've got a robot tending this Studer grinder. They do spindle shafts, of course, all the different kinds of shafts, transmission shafts. As you can see here, we've got a large variety of different output shafts. Anyway, let's head around here. More cylindrical grinders. And then right past these machines here are our gear hoppers, and we'll take a look at that in a minute. But let's head this way. Over here, we have this giant, this is our newest gear hopper here. this giant modal gear hopper. And we bought this primarily to focus on the largest rotary gear sets that we make. Now you peek in here right now, this is an HRT 310 gear, if you want to take a look in there. But really, this is focused on HRT 600, 800, and 1000 rotary table gears. So really large gear sets. Anyway, huge gear hopper. Now over here on this side, we've got really the bread and the butter of the gear hoppers here. These focus on HRT 160, 210, 310, and up gear sets. And the thing here is, these are, we've got millions of dollars of machinery here, but it's not just the machines. You can't put these into your shop and expect to be making high precision gears that fit perfectly and yield really good rotary accuracy, a week later. You also have to have the crew of professionals that have all the wisdom and the knowledge to make those machines run correctly. And that's what we've got here. All right, this is our inspection room here, considerably quieter than the rest of the factory. This is just another example of Haas's commitment to quality. We've got a huge variety of measuring tools in here, but probably you'd say the star of the show are all the different CMMs we've got here. This largest one is 3 by 1.5 by 1.5 meters. We use this for measuring our largest castings. We have a variety of other measuring tools. We do something like 15,000 tools that we calibrate every year. Super accurate measurements are the norm with this Wenzel WGT 500. With air bearings on all axes, a granite base plate and guides, hydraulic rotary table, and high-resolution scales, this unit has accuracies in the micron range, as we use it for daily inspection of worm gears and shafts and other gear and spline forms. Using this scanner, we can compare a live scan to the CAD model of the part. Accuracy is within 2 thou over 5 meters, and is even more accurate over shorter distances. This is a great way to evaluate complex castings prior to machining. And the results of these scans can even help our setup machinists decide how to best fixture and probe a new casting. Anyway, all kinds of cool stuff in here. Well, let's head this way for now. All right, so here we're sitting in front of these giant MPCs, focused, of course, on huge parts. We've got UMC bases behind us, big SD50 base here. Anyway, you can see that these are pallet-fed machines as well. You can load your part here while you have another batch of parts running on the machine. So it's kind of the same idea as the other FMS systems, just for much more massive parts. All right, we're just leaving the machine shop side of building 1. So we've just done 1/2 of building 1. We got a long way to go. But out here, it's kind of an example of, just the basic infrastructure of the factory. You can see here we've got compressors, and we're looking at about 650 horsepower, something like 2,700 CFM of airflow. That's quite a bit more than your standard shop. Past that, we've got our coolant recycling area, and on average, we're recycling about 3,000 gallons of coolant every month. We evaporate the water and then recycle all the used oil, of course. Also here you can see our propane area. This is where we have all the propane tanks to fill up the 200 or more forklifts we have driving all over this place. And then you can see these castings here. Anything that's marked with red like these are our first article castings coming in from inspection from our casting vendors all over the country and all over the world. So let's keep moving, and we're gonna go head on over to building 2 to look at some more of our machine shop. All right, so we just walked into building 2, and this is of course the machine shop side of building 2. In fact, all of building 2 is pretty much machine shop now. Behind us are, of course, more FMS cells, and really it's the same story. We use these to build a high mix of different parts. On this side, these machines are mostly concentrating on aluminum these days. But the idea here is that overall in this machine shop, we have about 60 machines dedicated in FMS cells and over 1,000 pallets. So I don't know if it's the biggest in the world or in this country, but it's huge to say the least. All right, so we've left the area with the FMS systems. Now we're back over in another area devoted to really large machines. This right here, this VB3 from 2005, I think it is, you can see it's still being used. Right now we've got an EC 1600 table sitting on here. They've got a rotary control box hooked up to it. Not sure what they're doing, but they do kind of one-off stuff on that machine from time to time. And then right here we have more of the older MPC double column machines, focused of course on the largest castings. These have been here for a long time, but still chugging away. And then on this side, we've got these Akuma MCRs. This is just essentially a newer, a little bit more sophisticated, quicker version of the same thing. All of these machines, of course, are pallet fed. So you've got a part waiting to go. You've got your part being machined, and then as soon as it's done, it moves out of the way and you load another one, so you're maximizing spindle on time. All right, this is going to be the last FMS that we'll look at today. This here is one of the largest FMS systems in the entire world based on the number of load stations and the linear number of pallets involved. Here we've got a really large mix of parts. You can see all the castings up there on the pallet wall. Lathe spindle heads, lathe gearbox housings, tailstock housings, just a really wide variety of parts, all made basically just in time for the production line. So now we're entering an area that's filled completely with Haas machines. As you can see on this side, we've got one of our robot cells. This cell is dedicated to building columns, just VF1, VF2 columns, very high volume. In here we've got 4 of these cells with E6 1600s tended by robots. We're building columns over here, tables and saddles over here, saddles there as well. So these cells are all dedicated to making 1 or 2 parts at very high volumes. These are machines responsible for keeping our small and medium VF casting lines running continuously at really high volumes. So now let's head on to this side. So all of these cells use 260 EC 1600s manned by a robot in the middle. On this side, we have a different configuration. This is typical of our other kind of robot cell. Here we're usually looking at 2 lathes and a mill tended by a robot in the middle. These are mostly focused, of course, on making round parts, spindle shafts, a variety of round other flat parts. So this cell here is an example of one that's dedicated to just one part. These are 40 taper spindle housings, of course. We go through a whole bunch of these every day, probably upwards of 50 of these a day right now. So this cell is dedicated just to making those. Now let's head back this way. We're going to take a look at what we call our batch production area. And that's just a big group of Haas machines dedicated to making a whole variety of different parts, mostly on the mostly smaller parts, turned and milled parts. Let's head over here. So this is what we call the batch production area. This is really the area of our shop that's the closest to a regular job shop. We've got a variety of mills and lathes. This particular area is a little bit near and dear to my heart because back in another lifetime here when I was a manufacturing engineer, these 4, actually most of these machines here, but these particular super speed VF2s, a little bit older, these are all around 2008 we put these into place. And at that point I was the guy that was responsible for doing the factory floor layout, making sure these machines came into place and older ones got moved out in their place. But you can see here we've got a testament to how long these things run. These have all been here for 11, 12 years or so, running non-stop. So let's head back out of here. And just like a job shop, this area is really focused on doing shorter runs of parts, stuff that the line needs right now. Now we're going to head from here and we're going to actually finally leave the machine shop and we're going to head towards assembly. Okay, so on the left here we have electrical assembly. And we've pretty much divided this area up into two different distinct areas. This is the control cabinet assembly on this side, and then over the wall, we've got electrical sub-assemblies.
We put together the control cabinet in a 20-step assembly process with 9 minutes of assembly time allotted per station. We start with the chassis plate, of course, and then add the major components like the transformer, the vector drive, I/O and main COM boards, and the amplifiers for each axis. At the same time, in the electrical subassembly area, we're building all of those major components and a host of other supporting ones that go into the control cabinet. Each control is built and serialized to match a specific machine sales order. It is configured for the options selected and to match the electrical requirements for the part of the world it's shipping to. It meets up with that same machine about a week after it's built on the machine assembly line.
Okay, so we're leaving electrical assembly. Now we're getting into the actual assembly where we put the machines together. On this side, we've got large VMCs, and on this side, we've got UMC assembly. We call these the cast assembly areas. This is where we put the foundation of the machine together. If you look at this VMC, for example, right here, you can see we've got the base, saddle, table, column, spindle head, and we put these machines together all quite in quite a similar way, really. It's what we call the stacked axis method. It's pretty simple, really. We start with the base on the ground, lay down the linear guides, then the saddle, then the table. Typically, we build the column offline separately. We'll put down the linear guides and ball screws there, and then we'll attach the spindle head to that, and then we'll lift that column assembly and put it onto the base. And there you've got your entire basic machine assembly ready to go. Then from that point, it leaves this casting assembly area here, and we move on to what we call the final area. So this is the UMC final area. A few years ago, it was only the UMC 750. We've got one of those right here, of course. But these days, we've got the smaller brother and the larger brother to the 750. That's probably UMC 500 right here. See, just a little bit smaller, small footprint. Moving from that to the biggest one we're offering now, this is the brand new UMC 1500 Duo, in this case an SS version. Here we've got the trunnion rotary table and a VF2 table. So you've got two complete different work envelopes you can take care of. Lots of possibilities here. Let's go across the aisle. Now we've got, over on this side, we've got UMC 1000 SS. So the super speed big brother to the 750 and the 500 right here. So of course, when we come to the final line, the idea here is after the casting assembly is done, here in the final line, we take care of the geometry of the machine, aligning all the axes. Then we put on the sheet metal, install the control, and then do all of the testing that goes into making sure that the machine is ready to go.
Amongst the many tests each machine sees before leaving the area, it will have gone through a final geometric alignment check. Checks like squareness of the z-axis relative to the xy plane, and spindle centerline to z-axis parallelism, and then a laser rotary accuracy check. This Renishaw XL80 laser interferometer allows us to measure rotary rotational accuracy with precision to plus or minus 1 arc second. This is followed up with a ball bar test to check proper alignment and motion of the axes. And of course, we perform the test cut to check actual cutting performance.
Okay, so leaving the UMC area, now we're entering where we build all of our EC machines. This is our brand new EC500 50 taper, just released. This, I believe, is the first one. Right beside it here is one of our EC400s, pretty much in the same stage as those other machines we saw. Here we build these machines all in one spot. We don't have a casting area and then a final area because the production levels are lower, and since they're even larger, we typically like to just leave them in one spot and bring the sheet metal to them as we assemble them. Now let's walk through. This is where we build our GR gantry routers and our GM gantry mills. You can see this right here, GM25AX. Got this 5-axis head on here. This has got the extended Z travel. Super capable machine for doing really large 5-axis parts. So now let's leave this GR area and we're gonna walk straight back over here. So now we're in large VMC final area, and this machine is an example of one that's in the middle of getting the geometry checked. It's kind of the same for all these different lines. You get this machine out of the casting area and you're gonna line up all the geometry of the different axes, make sure everything is square, perpendicular, and then from there you're gonna start installing the sheet metal, and then it goes through the whole plethora of different tests leading up to the final test cut.
Okay, we're gonna head back into the machine shop one more time to take a look at a couple more cool spots.
So these cells here are an example of how we do kind of medium volume, medium sized castings and keep the spindles turning as much as possible. Here we've married up, we've got a whole bunch, like 7 of these cells, and typically it's a VS3 married up to one of these Midaco pallet changers. So here's the pallet changer, and up here, of course, is where the machining is happening. So we've kind of run two different things here. Medium-sized lathe bases, small lathe bases, and then on some of the other cells we run medium and small VMC castings. So let's go walk down this aisleway here. So we've been running these VS3 cells for easily more than a decade here, but more recently we've teamed those up with these Mitaco pallet changers. And it's the same idea as we see on even the FMS systems and any of the EC400s. You're carrying multiple parts so that you can keep the spindle turning the entire time. You've got one part staged, one part being machined, so you keep that spindle turning. Let's go through here. We can see more of these pallet changers. Here we are where we're getting ready to load these small VF bases onto here so that machine will run those. Got one more thing I want to show you before we leave this building. Here we have two cells dedicated to making just the side mount tool changer cams. And we used to have EC630s that were custom modified, making these castings. So quite a sophisticated machine. And these are sophisticated, but it's kind of a more simplistic approach. If I come in here, you can see this is just a VF3 with a customized TRT 210 rotary table on here. It's just essentially an offset platter mounting, and these cells are dedicated to cranking these cams out all day long, every day. Got another one right over here, and that's just because we make a lot of tool changers every day. Let's head this way. We're going to take a quick walk through the casting yard here. Okay, so we're entering the casting yard here, as we call it. This is a favorite for when we're doing real live tours, of course. Now, this is where we hold the bulk of our castings before they get machined. As you can see, we've got castings on every side. Large VMC columns over there. Small, medium bases here. Let's keep walking this way. More medium base castings here. We're looking at around 7 million pounds a month right now, 350,000 some odd pounds of cast iron machined every day here. We get our castings from pretty much all over the world. USA, Canada, China, Thailand, India, Poland, and all of those castings go through the same rigorous inspection here. They all have to meet the same specifications no matter where they're coming from. So as long as they meet the specifications, we're good to go. Here are some more similar castings. We have UMC castings back there, UMC 750 castings. Here we have EC400 base, runs the gamut really. And what's crazy is that all these castings here, this is about a 1 month supply. We'll turn all of these castings, or pretty much all of these castings, over every month. So it's a huge amount of cast iron we're talking about. Let's keep walking through here, and we're gonna head to building 4, our inventory building, and take a look at the huge pallet racks and the narrow aisle equipment over there. Let's head this way. So this is building 4. This building houses all of the inventory for the entire factory. So in a second, we're gonna see all the inventory racks. But right here, you can see we're actually doing assembly work here. This particular line is dedicated to small and medium enclosure assembly for the VMC line. It's our highest volume line, so we put them together here, roll them over to building 1, just a more efficient way to put together these large enclosures. Let's keep going this way. Now we've got kind of a mix of regular width aisles here, and then as we'll see in a second, we also have narrow aisle equipment, just to get more density, of course. You want to store as many parts as possible. We store literally tons of sheet metal here. Sheet metal is really the biggest space hogs, if you will. So we store a bunch of it here. In front of us here is where all the incoming inventory is handled. We typically fill and then clear this area 3 times a day. We've got some nearly 700 vendors worldwide. So all of that inventory is coming in onto this dock and then disseminated into these pallet racks every day. So in this building, we've got 34-foot high ceilings, 10 feet higher than any of the other buildings in the complex. We have precision flat floors with guidelines in the floor.
for use by the narrow aisle fork trucks. When we were putting this building up, we used 1.5 million pounds of pallet racking, and that gave us 17,000 pallet spaces. We have more than 20,000 different part numbers in this area and over $50 million in inventory. Typically, we're looking at about $1.5 million a day coming in from our various suppliers all over the world. As I said before, we're somewhere around 675 suppliers worldwide. We're looking at typical inventory levels of 10,000 ball screws and 30,000 linear guides at any time. We stock components from THK, NSK, Bosch, ENA, Steinmeier, and SKF. Our total consumption of these two critical parts is around 33,000 ball screws and about 87,000 linear guides every year. So this is the service parts shipping area here in the factory. This is kind of on one side of building 4 here. You can see these are all orders going out to our dealers. We hold about $10 million in stock here, and that's in addition to the $75 million or so that are held at all the HFO consignment stocks around the whole world. The idea is for dealers to ship service parts from their warehouses or to have those actually in the service vans that are going to the customer shops. But whenever that isn't the case, we're shipping those parts next day from here. And typically, we're maintaining a 99% same day shipment. And if you go to our service webpage and you page down a little bit, you'll see that we actually post what we're maintaining service percentage shipment wise every day. And typically, we're above 99%. Pretty amazing. That means that if a customer needs a part, they're gonna get it as soon as possible. So we're headed back towards building 1. We're gonna end up finishing up on the building 1 assembly side of things. Just left building 4, but I just wanted to mention here, this is what we call our freight consolidation area. Most of these machines are headed overseas, but sometimes we even gather together larger shipments that are headed to the US. But the idea here is large groups of machines all headed to the same HFO that we want to group together in one shipment. So we've got machines staged here going all over the world. Who knows? Maybe one of these machines is headed towards your region now. But for now, let's head back to building 1. We're going to take a look at assembly. All right, now we're back at the very front of building 1. Actually on the other side of the wall where we first walked in at the beginning of this tour. Now, this is the rotary assembly department. Rotary tables and indexers, of course, is where Haas got its start. Nowadays, we're surrounded by a lot more than just the basic indexers and rotary tables. Haas has been making programmable indexers and rotary tables even longer than we've been making CNC mills and turning centers. Maybe you'd think that years ago we would have been content to sit back as the market leader in rotaries and sell the same products we developed 10 years ago. But not at Haas. We always keep trying new things. We were making 5-axis trunnion cell rotaries as far back as 1988. And we've never stopped developing new ways to make 4th and 5th axis machining more accessible and more productive. From our tiny HRT 100 to the mammoth HRT 1000 rotary tables, and 5-axis options from the TRT 70 all the way to our just developed TR 500 SS. We're always looking for ways to help you put more axes to work on your milling machine.
All right, so we're coming from rotary assembly into VMC assembly, and that's probably fitting because that's basically the progression that Haas followed from rotary tables to vertical machining centers. So this is the cast assembly area, and this is actually this assembly line, what we call a flow line. We just put it in place recently. Really, this is just a more efficient way and maybe a little more consistent way to put together VMC columns. In this case, small columns. This is our highest volume column assembly that we make here. You can see that this is kitted, ready to go, so that once it's assembled here, it's taken over to this side. This is where we do the entire stacked axis method we were talking about earlier. We place the base on the ground, add the linear guides and ball screws, install the saddle and table, and then we take that column assembly that we built over here, lift it with a crane, drop it onto the top of this guy here, and you essentially have the bare bones of the machine. Then we take this finished bare bones machine here, and we take it across the aisle, and we head into what we call final assembly.
Like we saw on the UMC line, here in VMC Final Assembly, We conduct numerous tests to ensure each machine is ready to provide accurate, dependable results day after day. Geometry tests like T-slot parallelism, saddle and column squareness, and spindle sweep verify that the machine is in correct alignment. Then we move to dynamic checks like ball bar and spindle vibration tests to verify that the machine does what it's supposed to while in motion and in the cut. All of these culminate in the test cut we run on every machine before it ships.
We're going to leave VMC assembly and head towards lathe assembly. Now we're entering the lathe assembly area. As you can see right here, we have some assemblies that are getting ready to be put onto this line. Wedge assembly here with the turret attached, all ready to go. Over on this side, we have spindle heads ready to go on the line. Another wedge assembly. Now, over to my right-hand side here, this is where we put together the small lathes, ST20s. And then over on my left-hand side, this is where we put together the ST30s. Now, similar to the mill line, we have a cast area and a final assembly area. This is the cast assembly area. Kind of the same idea here. You place the base on the ground, put down the linear guides and ball screws, and then you start adding all the large sub-assemblies. In this case, let's get back to this one here. Now you see here, we have a base casting where no assembly work has been done yet. Just getting ready, they'll level this out, then they're ready to put on the ball screws and linear guides. Right here we have an assembly that's progressed along a little bit farther. This is the bare bones spindle head right here. Here's our wedge assembly and the turret, tail stock. These are kind of all the main components that need to be on this lathe to turn into a functional machine. Ball screws, linear guides, everything's been installed. From this point, they're going to attach the control, and then they'll start building the sheet metal around it after they've made sure everything geometrically is moving correctly. Let's go from here down to the final line. So here we are on the lathe final line. This, of course, is the small lathes, ST20s, 25s. This ST25 is, well, looks like it's almost ready for shipment. It'll be completely final packed up in a minute here. It's running the last series of tests to kind of exercising the control and the axis motion. Once again here, I'm beginning to sound like a broken record, but
The idea is the same in lathe final as we saw on the mill lines. Test the machine thoroughly so we know it'll perform as expected when it's in your shop. Again, we'll double check geometric alignment with tests like spindle axis to Z-axis parallelism and tailstock alignment. Moving on to the dynamic tests, we'll check spindle vibration on these much larger spindles, just like we do for the mills. And yes, lathes get ball bar tests too. X to Z axis, Y to Z axis. We need to ensure the axes get to the correct position and do it smoothly throughout the full range of motion. And of course, we test cut our turning centers just like we do our VMCs.
then we install whatever options are attached to that order, test those, and the machine's ready to ship. It's going to go from here out to our shipping area. Let's take one more walk and finish up in the shipping area. All right, here we are at long last at the back end of building 1. This is the shipping area here at the factory. And this is, of course, where all of those machines and all those different assembly lines end up. And they get packed for shipment to an HFO near you or a machine shop near you. We'd like to thank you for joining us on this whirlwind tour of the factory here. And we really hope that the next time you're in town, you can join us here for a real live tour. Thanks for joining us, and we'll see you next time.